Let's see, we've gone through our inventory of getting our ground. We have our mat, we have our anti-static strap. We have our anti-static strap also grounded to the wall. We've tested the wall. We know the plug is good. We have also checked our humidity, 34%, 79 degrees in here. Not bad. We've got our fork out. So we've done our preliminary. And for our parts inventory, RAM, motherboard, processor, case, power supply, video card, NVMe drive, any other various unsundry items that we'll be using as we do this. Hello everybody, welcome to Build or Buy. We're going to be building a Threadripper 2nd generation today. This is probably the most interesting project we've had yet, and we've been building computers for a long time. It's one thing to build a computer, it's another thing to talk about building a computer, but it's a completely different animal to talk about building a computer while you're trying to show it and still be behind and in front of the camera. So we're going to see how well this is going to work. We've got 4 cameras set up here to do this with, and the reason we're doing this is I think this is something everyone ought to have the experience of. And every good computer starts with a great motherboard. And the motherboard we've chosen is the Gigabyte Aorus Xtreme X399. Now, why that particular motherboard? Because we're building a 2nd generation, the number one reason to get this motherboard, it has the new power distribution system, so it can handle the higher wattage, 250 watt. Now, we're not using the high-end CPU, we're using something a little bit lower that we think is more bang for the buck. But I'm just saying, 2nd generation Threadripper, 2nd generation motherboard. Now, the chipset is an amazing aspect of this because it is the foundation of every system. And our goal today is what we want to do is get this system built, and I'll tell you what the fork stands for in a couple of minutes, because there's some interesting technology that goes on with the X399 and with the X299 chipset. Now, if you build Intel, X299. If you build AMD, X399, and that's what we're going to do because we got 66 PCI lanes. Now, for those that think that's not enough PCI lanes to deal with, then you're looking at something epic. And I'll never say never, but who knows? We might build an AMD EPIC later for 192 PCI lanes. Options on motherboards on that: Gigabyte for a single CPU, which would probably be the easiest way to go. A dual CPU for an EPIC machine, maybe Supermicro. That's usually the way you go with servers. Now, this is a desktop machine, but this is a high-end desktop machine. So even though they sell this as a gaming with all this whiz-bang stuff with lights, has nothing to do with performance. Our goal, purpose, and intention for building this Threadripper is for editing audio and video. And because audio and video has some interesting requirements, we're going to get into some of that kind of stuff. Now, why the fork? Why the fork? Because PCI Express Bifurcation. For those that are interested, you can do PCI Express Bifurcation on the X299 chipset. You can do PCI Express Bifurcation on the X399 chipset. Now, what does that mean? Think of it in terms of a fork. A fork has 4 different tongs on it. Each one of those, say if this represents 16 lanes, each one of those represents 4 lanes. So 4 tongs on that fork. Why is that important? Once we get into the layout of the board, and I'm going to go through it not necessarily top to bottom, but categorically, like processor, the socket, the video, all that kind of stuff. But when we start looking at the sockets for PCI Express Bifurcation, what that means is you can take one of those 16X slots, you can split it. And if you're going to do an NVMe RAID card that would support 4 NVMe drives, you need to have a chipset that will support PCI Express Bifurcation. Now, you can do it on the X299, you can do it on the X399. If you do it on the X299 for RAID 0, 1, or 10, RAID 0 on the X299 will do it right off the bat, no sweat. But if you need the other 2, you're going to have a VROC chip, and it's a specific VROC chip, and you have to use specific Intel SSDs. We don't have to play that game because we're using the X399 chipset. All we have to do is, if we decide to add an NVMe card into this, pick the slot that's 16 lanes, and then go into a setting that says change that from 16X to 4x4x4x4. And that will allocate that resource so we could put in 4 NVMe drives and then turn that into RAID. Now, why is that important for this? Because Our scratch drive for editing video and for rendering any audio we do, for now, we're going to use a 2 terabyte SSD. So we'll go from an NVMe drive for the applications, a 2 terabyte SSD for the scratch, then we'll have another hard drive of say maybe 4 gig that we'll use for our downloads, and then we have another drive, probably 8 or 10 gigs, that we'll use as the offload for the backup that we store everything in. So what we want to do now with the SSD is we're looking at bang for the buck, that when we change that from 2 terabyte SSD to a 2 terabyte NVMe drive, we want to be able to RAID that and make that an incredible speed so that anything we render will render as quick as possible. Plus the video card. The video card that we're going to put in here is not bang for the buck, it's overkill. But our goal was we built 8350s in 2015, 2016 we rebuilt. In 2017 we built a Ryzen. Now we've got some videos up on Builder Buy I can show you, you can go look at. One in particular that talks about the Ryzen for rendering. We use Vegas Video mostly. We also use Magix, and that's going to bring up some interesting points. I'll talk to you about Magix. I'll bring it back up in a minute about Magix. There's two main video applications. One is Magix Vegas Video. I've been using that since the beginning. Then there's DaVinci Resolve. And DaVinci Resolve is a great program, but when it's in beta, it always breaks. There's DaVinci Resolve, the free version. There's DaVinci Resolve Studio, which is the paid version. And the paid version is incredible. But because of resource allocation, I'm going to show you some of the stuff that I have concerns about as we get into this. Even though we have a lot of PCI lanes, I'm going to go through this categorically. So first thing we want to do is get this built. We're going to get this in this video up and running where we have Windows 10 Professional installed. Hate it, love it, like it, leave it. If you're going to run this machine with the current drivers, that's what you're going to have. Two issues I've been made aware of with building a Threadripper. One, with the BIOS getting corrupted, extra batteries, because the battery, even though it's brand new, could be low on juice. So that's an easy fix. Number two is ESD. For those that have had a machine that after a couple of months it just dies on them, to me that sounds like a catastrophic electrical failure, which is typically electrostatic discharge. So the way to deal with that, we've got our anti-static mat, we've got our strap that I'm going to put on. This is grounded to the mat. The mat is plugged in and grounded to the wall. I've also used my circuit tester and I've checked to make sure I have continuity and that my ground is good. You need to have ground. So I'm going to put this on, and I've also got gloves. I'm going to go the whole 9 yards with this because I want to make sure that we don't have a problem with ESD, with electrostatic discharge. And I'll show you the gloves. These are not permanent gloves. These are temporary like gloves. This reminds me when years ago we went through the factory at US Robotics. That was quite an experience, quite an eye-opener. Never forgot it. We never got any closer than 25 feet to the assembly line. Why? Electrostatic discharge. We had the special little booties, the special uniform. They wanted to make sure that we didn't cause any problems because electrostatic discharge is a serious business. Wow, those are tight. But we want to make sure that this build goes accordingly. So I'm going to put my fork up. Hope you like that for PCI Express Bifurcation. Actually, it's two words. Bi, meaning two. Furcation, or forcata, which is the Latin for fork, medieval Latin. Okay, we checked our humidity. I'm good to go. Now, the last time we were going to do a Threadripper, we were looking at components and cases. And this time we're going to start with a motherboard. And for those that have seen the video about the case, we didn't use any of those cases. Oddly enough, though, we went with the same brand, just a different model. Now we need to test this motherboard and make sure it works as is. Any upgrades or changes we make, that's something we have to consider and deal with accordingly. And this is a big motherboard and it is a heavy box. Now if you'll notice, there is no seal on this box. That's a disconcerting thing. No seal at all. It's just a box. Aorus X399. We've always had seals on boxes. That's the way you know it not to have been tampered with. And even when we open it, there's no anti-static bag. There's just this piece of plastic. Now I've taken the liberty with the case and pulled all the plastic off because that's always where I've had trouble with static in the past. And because of the sensitivity of this motherboard in this case, that is something we don't want to have happen to us. So I'm going to get this board. And the first thing most people are going to ask is about the socket. Whose socket do we have? Now the camera is on autofocus. I think it'll be easier for me to deal with as we go through this. Hate it, love it, indifferent. This is a Foxconn socket. So for those that are asking, this particular board has a Foxconn socket. Now I'm going to get this out and lay it on this panel. Up here on the top we have a piece of plastic over this cover, and I'm going to pull that plastic off. I'm going to go ahead and get the motherboard out of the box. Now in the bottom of the box is all the goodies. We'll need those goodies a little bit in just a minute, but for the moment I'm going to just set this up here so we can get this out. I've never seen a motherboard wrapped the way this one is. This is really interesting the way this is wrapped in here. I would think that cardboard would just fold down, but it's going to cause breaking the seal when I do. It's not what I wanted to do, but there's no way to just pop that loose. I'll set that over there for just a minute. I've never seen a motherboard package like this one is. Got to turn that around so I can read it. That's just a piece of paper. We've got all of our I/O here in the bottom. Okay, we've got straps. We've got a couple of cables. These look like the thermistors for checking for heat. Over here we've also got, that looks like a bridge. Yep, 2-slot bridge for a video card. We've got SATA cables, 1, 2, 3 SATA cables. I also see the standoffs for the NVMe drives. Over here we've got the Allen wrench we're going to need, and somewhere in here there should be a T20. There it is. That's for the socket, a T20 socket to get the CPU down. And then we have some stuff here for, looks like that deals with the LED lights, of which I'm not interested in. Once I get it up and running, I want to turn that off. And there is a driver CD. Because I am tethered, I have to stay fairly close. One thing I would recommend is get your manual as a PDF file from the website so you can look at resource allocation and see how that's all gonna lay out. Multilingual installation guide. We are going to need some of these parts even before we get the socket. Okay, we got the motherboard out of the box. We've taken the plastic cover off of this shield. We have another plastic cover on this shield. We'll get that off. That shield does not have. The only way to effectively get that out is to break that out. That is in there so tight. That is a heavy motherboard. I can finish taking this plastic off. Now what's interesting to note, I'll get this out of the way. We set the motherboard down. It's interesting, I had to break that out of the box to get that out of the, never had to do that. I've always been able to keep a box intact, but it is what it is. Okay, we've got the motherboard out of the box. There was plastic we peeled off of here, and there was plastic we peeled off of right here. Now, as we look at the resources going down the line, underneath this cover, I'm going to flip this up on edge. This is the I/O panel, and the I/O panel is already attached to the motherboard. Never had that before. But as we look at the resources, the first resource here that I'm going to talk about is this network connection. This card is underneath this cowling, this shield, and to swap that out, we've got to figure out how to take that off. So to get that out, now this is an interesting example. For most people as a regular user that's going to use this, an issue you're going to have doing audio, especially audio, with the snap, crackle, and pops, will come from your wireless. This motherboard has wireless on it. This Bluetooth on here is 4.2. If you want to change out that Bluetooth to Bluetooth 5, which would be great, you're going to have to accept the fact if you have latency issues, and there's a program once we get the Windows up and running that we can look at and talk about latency. That's the first thing that's got to go. 2 issues people have had getting their system up and running. 1, the wireless. To deal with that, I've got the new version of Windows on this thumb drive as of about 2 days ago. We're going to install and see, but just to FYI, for Windows 10 64-bit, again, I don't know if they've dealt with that issue yet, but I'm curious about getting this cowling off so that we can change that wireless card out if we choose to, or if we choose not to be able to take it out to disable it, not just to shut it off in the operating system. From what I can tell, there's no settings in the BIOS to shut it off. There should be. Let's look at the I/O panel. Whenever I'm looking at a motherboard, I like to look at the resources. It's one thing to read about it. It's another thing to look at it. On the I/O panel, we've got a power button, clear CMOS button. We've got 4 USB 3 ports, USB 3.1A if you want to call it. 2 connections for the Wi-Fi antenna, and that's a standard M.2 Wi-Fi card. We have 2 internet connections here, 1 gigabit Ethernet, and then we have 1 internet connection here for 10 gigabit. These 2 are Intel, which is great. This is a Quantia, I believe. Not a high-end chipset, but it's there. And we'll talk more about that, why you would have 2 of those when we get to that point. USB-C, which is the ubiquitous port where you can turn it either way. USB-C right here. Then we have the Sony Philips digital interface, and of course your connections for your speakers. Now, as we look at the motherboard top down, and I'm looking at this where I hope you can see it. The first resource we talked about was right here where the wireless card is at. We've got 2 power taps here that you have to have. Those are 8-pin. Over here we have the other power tap, which is the 24-pin. Those are mandatory. There is another power tap, 1, 2, 3, 4, right here. And let me move this just a little bit. The only optional power tap you have is this one right here. That, and I'll pull this up on edge, that power tap right there is for the PCI Express bus. So say you put devices in all the slots, then you want to put power to that. You've got 6 SATA ports, and yes, originally when we looked at the specs, we were concerned about 6 SATA. The X399 allows for 8, but again, it's resource allocation. There's other stuff going on here. So I want to keep going around the board because right up here at the top, that's for a CPU fan. That's also for an optional CPU. Then you've got your headers for your RGB lights. You've got a fan header, but right here, this one, we've had that header for quite some time, but trying to find the connector for it has been a problem. That is the front USB-C, the USB 3.1C, the ubiquitous port like we have on the back that'll go either direction. We have an I/O device that we can put in a drive bay to give us access to that port. Now, the drive we've got fits in a 5 1/4 inch bay. We can use that. We can also use on the bottom of the board where we've got USB 2 and USB 3. You'll notice down here, we've got 2 headers for USB 3. And these are the 19-pin connectors. So on the case we're going to be using, and the case is the Corsair Obsidian 750D Airflow Edition. Still the same problem with cases they've had in the past, terrible feet. But otherwise, it's interesting. That case came the closest to doing what we need to be able to either have a liquid cooler or to have an air cooler. And I'll get into more of that later. But back to resource allocation, where we have USB-C on the board, as well as the USB 3.1A on these 19-pin connectors. Over here, we also have 2 block headers for USB 2.0. Now, each one of those gives us 2 ports. Each one of these gives us 2 ports. 2 of these can go to the front of the case. 2 of these can come out the drive bay. With these, we actually need more USB 2 ports than we have. But, again, resource allocation is kind of like PCI slots. PCI slots have gone away, and PCI Express is where we're at now. So I can put 2 of these out the front of the case, and if I put 2 of these out the drive bay, then I'm going to have a problem with resource allocation when I'm doing audio. Because even with video, for example, say you're using DaVinci Resolve. The free version, no dongle. But if you use the paid version, DaVinci Resolve Studio, there's a dongle. Now, I'm hoping they're going to eventually get this squared away where they'll have some type of activation server that works kind of like the way Magix does, but right now they don't, and it needs a dongle. The other programs that need dongles, and I'm going to show you an image. And what I wanted to show you here, right now, on an 8350 FX machine, I have 2 dongles. I have the iLock and the eLicenser. Then the third one would be the Waves, uses a regular dongle. And then, of course, as I just mentioned, DaVinci Resolve has a dongle. So that's 4 dongles I need access to. iLock, eLicenser, a regular for Waves.com technology, and then the 4th one for Blackmagic DaVinci Resolve. I've only got so many ports on this board, so I've only got 4. And if 2 of them go out the front on the case and 2 of them go out the front on the drive, I like to keep those dongles in back out of sight, but I'm going to have to rethink that theory. I even have brackets I could use to put on the back, but I'm going to use the ports on the front so that resource is allocated. Now, as we go from the top down, we've got support for 128 gigs of memory, but what we're going to do is we're only going to put 64 gigs of memory on here. Now, the memory we chose is not according to the compatibility list that Gigabyte has out, but I've taken a more historical approach to this. In the past, when we've had specific equipment that was very finicky about memory, I would go to the manufacturer and I would let the manufacturer show me, if they had support for a particular computer, which memory they said I needed to use. And this goes back a long time with both desktops and laptops. So with that said, I went to Kingston and I said, here's the motherboard we're going to use. What RAM can we use? And I'm using RAM based on their specifications. So we're going to see if that's going to work. We're going to find out. Low profile, well, that's another interesting issue with the case we'll get into, as well as with the cooler. But as we look at resource allocation, first thing we want to do is we're going to get this processor installed, and I'll show you in a minute which one we have. And we want to be very particular about this because of static electricity. Then we'll get the RAM installed. Or, as I say, get this on, get the cooler on, then get the RAM. So we're going to follow their procedure. Once those items are installed, then we have, now this will support 1, 2, 3 M.2 cards. These are M.2 NVMe. We'll put the first one in here. I'm not going to use 2 and 3. If we put any more in, it's probably going to be on a RAID card, which brings us to our slots. Video goes in slot 1 right up here. The card we're going to use is humongous. It takes up 2 spaces. We may not have access to this second slot. And as far as PCI Express Bifurcation, this is a 16x slot, and I believe this is a 16x slot. We'll double check when we get to that point. And I believe this one is an 8, and this one may be an 8. So you've got 2 16s and 2 8s, but we'll check. If it's not 2 16s and an 8, then it's 2 16s, an 8, and a 4. And then you've got a single lane slot here. What would you put in a single lane slot? If you wanted to add some USB ports, USB 3. If you want to add a SATA controller for more drives, you wouldn't get 6 gigabit, you'd get 5 gigabit because that's what it can handle through the bus, but I'm just saying. Considering how many lanes we've got and what we're going to do, this is a phenomenal board and should do what we want. What I'm going to do over here with the parts is I'm going to get these other items out so that they're ready to go when we are. We're going to need some of these little items out. So, okay, the items we're going to need, we won't need the bridge because we're only going to use 1 video card. Our SATA cables we'll need later, but not initially. I'm going to need these standoffs. So I've got 1, 2, 3, and then I've got the screws that go in there. I've never seen screws packaged separately like this for a motherboard. So 1 standoff and 1 screw. That's what we'll get out for right now. We're going to need the wrench to get the lid off, and I imagine this is probably a metric wrench. It's got a part number, but I'm not sure. I could check it for those that are curious. The power block in here, this is an idea that came about, I think, through ASUS, which is a neat idea in theory, but it's not practical. They don't stay on like you want them to. The Torx wrench T120, we're going to need that for the socket. Our bracket for antennas, we don't need that. The LEDs, we don't need any of this LED stuff. The thermistors, we'll deal with those later. We're going to get this thing up and running. So the parts we've got out, 1 screw, 1 standoff, and 2 wrenches. The Allen wrench, the T20. I'll keep these parts close by in case we need them. Okay, motherboard processor. The processor we're going to use, this is a Ryzen Threadripper 2nd generation, and this is a 2950. So it's interesting how we've increased our cores, we've increased our threads from the 8350 to the Ryzen to now the 2nd generation Threadripper. And our CPU is intact. I've read where some users have had issues where the processor they ordered when it arrived, it was rattling around loose in the box. That's bad, bad, bad. So what we want to do is get this wrench out that they provide, and it's very specific with the instructions. To open, 3, 2, 1. To close, 1, 2, 3. So to open, we'll go 3, 2, 1. And then when we close it, we'll go 1, 2, and then 3. And we've got the little tabs down here that have to lock in. Now at some point, I want you to be able to hear when I lock this down. So I'm trying to figure out how I can put a mic over here. Okay, we've got our motherboard. We're going to get our processor out to break the seal. I'll turn it so it's right side up to you. Break the seal. Seal is open. Pull the cardboard out. Aha. Okay, break the seal. And then this tab, we just slide it forward. And that should release, so that opens. It does. So let's get this open. 3. Well, that's down tight. And if you also notice while I'm at it, the spacing here, where the cooler will go, the spacing on the bottom end from here to here is different than the spacing on the top. Let me zoom in on that just a little bit. If you'll notice the spacing where the cooler goes on this, spacing on the top versus the spacing on the bottom. These two are closer together because of these blue tabs that have to be locked down. These are farther apart. That's important when we put the cooler on. Now the cooler we're going to use is not our first choice, not our second choice, but our third choice. We're not going to use a liquid cooler on here. That was our first choice. Our second choice liquid cooler turned out not to be such a good idea. Our first choice liquid cooler turned out not to work for us. Our first choice liquid cooler turned out to be a bust. We couldn't get the mount for it. Don't know when the mount will ever be available for it. The second cooler we looked at, also liquid, we were concerned about some issues with it. So we went with our third option being an air cooler, and we're going to use a Noctua. So that's why I wanted to point out what the socket looks like and how that's got a mount, because it's very particular. CPU out. We've got a little box down here in the bottom, Installation instructions. That's the bracket for the Threadripper, and that's the wrench. How interesting. That looks like the same size wrench. Ooh, I like that wrench better. Nice. As far as the bracket, I don't know if we're going to use that bracket or not. We'll see when we get to that point. So I'm going to set that aside. What we need to do now is get our CPU out. Okay, set that aside. And what we want to do, set this down. We'll finish getting this socket open. 3, 2. This is a much better wrench. Much better. I'll use this little spinner here. Get that all the way out. Now putting this CPU in this little device is almost like putting a drawer slide, or this is almost like putting a drawer in a drawer slide. So we're going to see how well this works. Now that's loose. Those are loose. So that comes up, and we want to be very careful and very particular with this lid that we're going to pull out. Okay, we've released the sled, and we can see the pins. The pins look good, so the motherboard looks like it's never been messed with. And we want to be very careful how we gingerly remove that. Slide that straight out. Take real good care of it. We'll get our processor. We should be able to pop that. Okay, so we've got to pull that out. Okay, so we have the sled up, the lid's off, taking the cover off, and the orange sled that the CPU is in, we want to be very careful. Handle that gingerly by the edges. Now we want to slide the CPU down into that sled all the way to the bottom. Now we've got that CPU slid all the way down to the bottom, and if you notice those little pins down there at the bottom, those little tabs that stick down, those are in where they need to go. And we should be able to close this, so there's no way to mess this up. We'll drop this down with these two tabs, and with the mic here you should be able to hear this. Okay, those two little tabs are locked down. Now we'll close the lid, and to close this we go 1, 2, 3. So let's see how this works. We'll hold that down, get that started. This is easier to spin with. 3, 1. Go back to this one. 2, 3. 1. Oh, that's not down yet. Okay. Now I see what people are talking about. So I'll go down again. Okay, 1 is down. 2 is down. 3 is down. You got to give that just a little bit of effort to get number 1 down. So we'll take number 1 all the way down. Number 2, number 3. Okay, number 1's at the bottom. Oh, it even has a lock on it so you can't over tighten it. Didn't know that. So it torques it. 2 and 3. 2, and it bottoms out. 3, and it bottoms out. So there's no way to over tighten it. 1, 2, 3. Okay, handy little wrench. Handy, both wrenches. I like using both of them. I've seen a lot about this, read a lot about it, and I don't know, I'm kind of flabbergasted. I can see where some people are having problems with it. And it's extremely important that CPU is put down correct, because if it's not, it will affect how the RAM operates. And these boards, because they're quad channel, are very specific in the arrangement of how the memory goes. So we're going to pay attention to that. But the most important issue is we are grounded. We have the ground strap on. We have the anti-static gloves. We've got the CPU down. It's been torqued with the wrench that comes with the CPU. We also used the wrench that came with the motherboard. And we did it according to what they said, and it's there. So the next thing we need to do now is get our cooler out, but before we do, I want to secure this socket and make sure it's protected. So I put the socket in the orange, and I take the black cover and put on top of that, snap that back down to protect it. And I will put that back in the box to protect it. Okay, processor's done. I like that. Okay, the next thing we need to do is get this CPU cooler on. This is a Noctua. This is a beast. This is going to have a 140 millimeter fan. It has a single fan, but we have the option to put a second fan on. The bracket is supposed to already be in the box, and yes, we've ordered the other fan. My concern is not only cooling for the CPU, but concerned about the RAM, and I'm more concerned about the video card. So I don't want this to sound like a hovercraft, but I'm not worried about noise right now. We're going to be putting some extra fans, one extra fan on this, probably 2 extra fans in the case, and I think we're good to go. So we're going to get this out of the box and see what we've got. Okay, the fancy little drawer that came with the CPU that has this bracket, we may need this bracket. I don't know yet. I don't know what the status is. It's supposed to have its own bracket, but I'm going to pull this out just in case. Another concern I had with the liquid coolers is they didn't fully cover the CPU. I won't get into what we were going to use. It really doesn't matter because what we're using is what matters. So let's get this out and see what we've got. Now, this says, I've got to turn around to read it, Tailor custom version for the AMD TR4 SP3. TR4 is what we're dealing with. So this is what we're looking at. And the bracket that we need is in this box. And we've also got, looks like an Allen wrench. It comes with an Allen wrench. It also comes with its own adhesive. Also an extension cable, which may be one of those that drops down the RPMs. The special bracket for the other fan, and then a clip. Not sure about that. So we'll check out 1, 2, 3, 4, 5 items. Oh, those are the brackets that make a fan run, supposedly make a fan run quieter. And there's the adhesive, and there's the bracket, and then there's the Allen wrench to put it down with. Nice and long. Has a ball foot on the end of it, so when you stick it in the socket to move, it'll move with you. This is a beast of a fan. This thing's huge. My concern was, and I didn't know when we were looking at this fan, my concern was that they had already put adhesive on the bottom of it, and I learned a long time ago with the FX machines, we were having difficulty with, we were losing motherboards and we were losing CPUs, is because the bond between the cooler and the CPU is breaking. So no longer do we use pads, and anything that has adhesive on it, I clean it. When we did that, we quit having problems. The problem was the 8350s were moved around a lot. They were in rack mount cases. So we'll take this out. It's got a cover on the bottom, so it's nice and clean. That looks good. I'll leave that on until I'm ready. We talked about doing this as a live build, but there's just too much involved, and most of the editing you're going to see is because of some things I need to do for scene changes so that it makes sense to you guys that are watching this. Okay, we got our cooler out, but I'm going to keep it as real time as possible. You can see this cooler. It's got, I'll turn it over here to the side. It's got one fan. It's got the clip that clips that fan on, and then it's got these little rubber mounts on the side. They're supposed to help make the fan quieter. We've got another set of the rubber brackets, as well as the clip we need to put a fan on the other side, which is what we're planning on doing. So first thing I want to do is get out our adhesive, 2 clips, 2 wires, and this is Noctua NTH1, premium grade thermal compound. I'm good with that. And then of course this is their coupler for low noise. It cuts down the RPMs. Well, I'm going to let the system choose how that's handled. Comes with a manual, talks about mounting, shows how to use the clips for thick spacers and for standard spacers. What I'm always curious of is when they talk about how to do the thermal paste. And they show putting dots. Applying thermal paste. If there are residual traces of thermal paste or thermal pads on your CPU, clean it off. Okay, CPU is clean, the pad is clean, the cooler, so we're good to go. Then press 9 small drops onto the heat spreader in a square 3x3 pattern as shown. Continue by adding 4 larger drops in a square as shown. Applying too much thermal paste will lower heat conductivity and cooling performance. And they don't even show spreading this out. They just say put it on there. I have always spread that out, but I'm going to put it on the way they say. Now I don't know if this has, yes, got a cap on it. Keep it clean. Yes, this has a cap. I've never used the Noctua paste. I've always used somebody else's thermal compound. So it's got a cap to keep it clean. So we'll follow their directions and put on the 6 dots, and then we put in 4 more dots. So we'll go down the center and around the edges. One thing I need to do before I do that is take a look at what's going to be required to get this plastic cowling off, because if we decide to remove this or to upgrade this Wi-Fi, this has to be removed. So there's a screw in the back that holds this down. There's another screw here that's holding it down, and a third screw here that's holding it down. So those 3 screws, which are Phillips head, Okay, we've got the CPU installed. Before I proceed any further with installing the cooler, while this is still manageable, I'm going to go ahead and get the M.2 drive in, and I'm going to look at the possibility of removing the wireless card in here, which means I've got to take some screws out. It looks like 3 screws on the back side to pull this cover. Then I can pull that card, and I can decide if I'm going to upgrade it. Even though this is a brand new board and we need to use it as is, it'll be a lot easier to do this now than trying to do it later. So the first thing we're going to do is go after this socket. So I'm going to get this little wrench out that Gigabyte provides. We're going to take this M.2 off the top. This is number 1. This will be our boot drive. So I've used the Allen wrench so I can remove the top cover. Set the screw and the wrench aside. We'll pull the cover off. Now this has a film on it that we're going to pull off. So when we put this back down, this heatsink will do some good. Normally it takes about 45 minutes to build a computer with all the stuff, but since we're talking about it and some of this is new to me and I'm sure it's new to you, I hope you enjoy this. Remember, any questions you have, please be sure and ask, and I hope you'll subscribe and I hope you're enjoying this, because the only dumb question is the one you don't ask. We try to answer everybody, and everybody matters. And we're going to install a 970 EVO. This is a Samsung NVMe M.2 1 terabyte. And now I've got to break the seal. It's kind of strange being tethered. I'm not used to being tethered building a computer. But then again, this is the first time I've ever built a Threadripper. I've built a lot of computers over the years. But I want to be sure we get bang for the buck out of this and we don't have any problems like some other people have had. And ESD, electrostatic discharge, is a pretty serious thing. It has a cascading catastrophic failure that will occur over time. Not fun. So the processor's in. We're getting this little stick of chewing gum out. We were going to build a Threadripper, then we weren't. Then we got to looking and decided now's the time to do it. And this computer should be good according to stats with the manufacturer, with AMD. We should be good to this until 2020 when they change sockets, new technology. Okay, there's our drive, the NVMe, our stick of gum. We're going to take that and we're going to need to move the socket, because if you'll notice, that's sitting at 110. We need it down here at 80. So I'm going to set that aside for just a second. We're going to see if we can move that standoff, or we'll just put another standoff in there. Now when that cover goes back on, that's held down at the 110 spot. Curious. So that 110 screw has to stay. The one we're putting in is where we'll use this on top of that. Get the right standoff. Now we're going to need a screwdriver, and we will need a number 1. I have 2 Phillips screwdrivers I use. A regular length and then a long one. The long one is especially handy sometimes getting into cases where you need the depth. Yep, number 1 tip. Screw that down. That's a straight blade. Same difference. Number 1. Okay. I use an extra long screwdriver. Okay, now we're ready to screw the standoff on, and that standoff looks like the other standoff, but this standoff is required to hold this down. This standoff is where the NVMe is going to sit, and it uses a straight blade, not a Phillips. So once that's secured, and this is an extra long screwdriver, this is really handy when you're having to reach inside a case. But I have a regular length and this extra long one, because you never know what you're going to run into. Okay, we'll go back to our NVMe, our little stick of chewing gum. Never handle the contacts. And if you notice, it's got 1 notch. I'll zoom in on that just a little bit further. And if you notice, it's got 1 notch right there. So this is a 970 EVO Samsung. We'll insert that at an angle, drop that down, and then we need to get the little screw out for this little packet, and that will take a number 1 Phillips. So a number 1 straight blade and a number 1 Phillips. Okay. We'll secure that drive with that screw, and that's 1 terabyte. Incredible. Now, there's a label on this stick of memory. I'm not going to pull that label off, but I should for this to stick. I'm only going to pull this label off. If I pull that label off, I lose my warranty. But I will pull this one off. And lock that in. Now, I've not had any trouble with these running hot, but then again, this is going to be underneath literally the video card. Get that lined up. and the special screw that goes in that uses the Allen wrench. I had read where others had alignment issues with this. I don't see any issues with alignment. Okay, that is secure. We've got the stick of chewing gum, our M.2 in here, a 1 terabyte NVMe drive underneath this heatsink. We're contemplating taking this cowling off so we can change out or disconnect that wireless. I don't know about you guys, but I'm kind of curious about the wireless, and I think we're going to see if we can upgrade it. Once we put the cooler on, it'll be problematic to pull the motherboard out, although we can, and we should test it with what's there. Let's see what we can do about the wireless that's there. This wireless, we want to upgrade it, and the card we want to use is a new Intel wireless, a new wireless that does not have Vpro. And this wireless card, once I take this out, we're going to need to attach the antennas to it. So let's pull this off first and see what's involved. We've got 3 screws. These will use 1, 2, 3. Once we pull these 3 screws, that cowling should come off. And these use a number 1 Phillips. There's 1, there's 2. And the only reason not to have any wireless on here is because of latency. Windows is not a real-time operating system. If we were going to use a superior operating system, well, I'll just say, does anybody remember OS2? Superior is not always the way we go. So now that that's loose, that also loosened the I/O cover, and that cowling should now be loose. I got 1 more screw. Okay, I've got 1 more screw right here to pull. They make us work for this. Apparently they don't want anybody doing this. Okay, so that should, the I/O panel should come out, and that cowling should come off. Well, they don't make that easy. So there must be another screw that I'm missing. Well, the I/O panel is loose. I wonder what was rattling. That cover right there is loose. Interesting. I don't want that rattling. That may have to come off. That's loose. I may have to pull this other screw out here. So let's do that. That may be all along there. Keep them lined up. So hopefully they'll go right back the way they came off. And those 3 screws all look different. Okay, so that's all loose. That looks like the only way to get those off. There is no standoff under there. So when that screw comes out, that's loose. That's what we want. But I don't see, that should come out separate. Unless that standoff is what holds that. And if that's the case, the only way to take, it looks like the only way to take this off is to completely remove the back. Because the back has to be off. Because there's 1 standoff right here. There's 1 standoff right here on the motherboard that's holding this down. And the only way to get it is to take the back off. We've got 3 screws. 1, 2, 3. And that should release the back. 1, 2, 3. Now that should come loose. Okay, there's a compound up here that holds that and protects the board. That released. There shouldn't be anything else holding this down unless I found another screw. Okay, 1 more screw right here, which puts that right here under this. So to get that other screw out, we've got to pull that off. Because that rattles, we may leave that off anyway. There's the other screw. So we'll pull that screw. Now that should take all the screws, and that should just lift right off. And it does. And we have 1 set of wires on this that we need to unplug, which I've done. So that should now be secure, and make sure that's going to stay where I want it. Can we now remove this cowling when we remove this nut? Oh, I've got some more screws exposed. Now I see. That's for the heat sink. So those are for the heat sink I shouldn't have to mess with. All I want to do is get this off, so I should be able to take that out. So let's see what we've got in our little box of wrenches. 3/16. Yep, sure making us work for this. We've got 1 more screw here on the bottom that's probably going to have to come out. And that should do it. There's that screw. Now, will that come off? Yep. Oh, there's another one right over here. Okay, I'm keeping these screws on this side. Finally. And there's 2 little fans in here. And there is our wireless card. Now then, what's holding the wireless card in? A bracket and 2 more screws. Okay. My gosh, that's a tiny screw. That's smaller than a number 1 Phillips. So now we get out the micro screwdrivers. So micro screwdriver to get that off. So we're going to take those two out. That module should just unplug, and it did. Okay, here's our module, and that is the card that's in there. Okay, if we decide to change this out, then we're going to use this card here that doesn't have a Vpro on it. I just happen to have a needle nose pliers, a jeweler's bent needle nose pliers, and I just happen to have a special mount. What we want to do is, it shows number 1 and number 2, is we're going to take this card. For those of you that are thinking about changing out that wireless card, you can see what's involved. And what we need to do is replace those pin for pin. So we've got to replace those wires. So what I'm going to do is pull that off the clamp, and I'm going to clamp this one in there. Okay, I've got the clamp, set it down tight to hold that in, and I need to pull these off and make sure we're in the same 1 and 2. Yep, configuration is the same 1 and 2. Yep, number 1 is on the left, number 2 is on the right. So we'll pull off number 1. Pull off number 2. Snapped in. Pull off number 2. Snapped out. And my big hand is in the way. Not sure I can get that where I want it. Two. Okay, if you'll notice, those are snapped right back in the way they were. Number 1 and number 2. Now what we have to do is take this out of the clamp. That clamp was extremely helpful. Okay, we have to get the clip back on to protect those wires. Wires are set. Get our clip on the top. Okay, that snaps right on. So I got that back in. That's down. Now that's going to screw back in. We got our card and our screw. So we're going to get this back together. Now this module really should be left out, but we've just upgraded it. Got the antenna snapped in, got the screw down on there. So what we'll do is stand the motherboard up with the fans dangling. Turn this over. And one of the fan headers came loose on me. I'll deal with that. We're going to take this module and plug it back into that slot, and then we'll put the screws back on the back side. Okay, and hopefully that doesn't come loose any more than it already has. So that little standoff right there was in our way. So now that will lay down like it's supposed to. Standoff here and a standoff right there in the center. So we plug this back in. That should line up. And yep, looks like the holes will line up now. And yes, I'll double check the fans again to make sure that they're still all in good order. I just don't want to unplug them if I can keep from it. Yes, that's going to line up nicely now. Okay. Now the purpose of this is to install a new Wi-Fi card. So we get not just Wi-Fi, but Bluetooth. Because for resource allocation, if you were to take that card and put it on a PCI Express card and stick it in a slot, then you would also have to use up one of your USB 2 ports internal to make that Bluetooth work. So it's smarter to have it here if you're going to use it. Now we've upgraded that, and that was a pain, but we did it. We wanted to see if it was possible, and it is. Okay, now the next thing we need to do is the reverse of all this other stuff. Let's make sure all these connections are still good with these little bitty fans. Those look good. Those look good. Our wireless module is secure, and you can see what we went through to get that installed. That was a pain, an absolute pain, but it's done. But it needed to be done now, or forget it. Now I'm just making sure these connections are tight. I'm just making sure these fan connections are tight, and they are. Now it's a matter of going the opposite, putting this thing back together. We shouldn't need the micro screwdriver anymore, but we do need to figure out how to get this cowling on with those cables. If those laid in the top, that would make the most sense. They're out of the way of airflow. So that's what we'll do. We'll keep those on top. I was so busy trying to get that off, I didn't pay attention to how it sat. And something in here is still binding. I'm not real gung-ho with the way that's done, because when those little fans go out, they're going to have to be removed, or else that's going to get noisy. Let's see here. I need something to move some wires out of the way. Something is not sitting down. Those fans sit right up to that heat sink and that little bracket that holds them on. I think we're making some progress here. Yeah. Okay, so those fans and those wires just sit there. That shouldn't be a problem when that's screwed back down. Okay, that little piece stays and that little piece stays. A standoff over here. That's our clamp. We're through with that. Not through with the sockets. Ah, here it is, the standoff. Okay, which one of these had the standoff? The standoff was... Okay, we had two little regular screws. Okay, that's two little regular screws. But that doesn't make sense for the standoff. A lot of work just to put in a new wireless card. Now we'll have two screws. That'll take a screw. Let's see. Messing up that pad again. When this goes back down, we've got to get these two screws back on. Actually three. 1, 2, 3, but number 4. So there's a standoff. Okay, that standoff goes there. The I/O would sit like this with metal screws. This should be the standoff. And these should be these screws. Now I need to grab that at that top edge and hold that in place while I flip this over, and they're there. They're there where they need to be, right on that metal bar. And I want to look at the edge of that, and yeah, they're covered. We've got these two screw holes to line up. We've got this one here to line up. So there's 1, 2, 3, 4. One from the other side. 2 from the other side. 3. Those are from the other side. So we're going to deal with the ones here on the back. Number 2 Phillips. We'll start over here at the shield. And 2 things we made sure of: that our connection is on, which is probably internal antenna, and that our pads right here are where they're supposed to be. So the first thing we'll do is screw down the I/O panel. Well, let's see. Before I screw down the I/O panel, I see one screw that is not a regular screw. So I need to look and see if I have left something out. So I need to hold this, turn this over. The only screws were for the cowling. That's the M.2. The machine screws, there should be 1, 2, 3, 4, 5, 6, 7, 8. So we've got, those are really shallow. So we've got 1, 2, and there's a shorty. 1, 2, 3, 4, 5, 6, 7, 8. I'm looking at 9, so I'm missing something. So I need to pull this back up and take another look. I've got a cowling screw right here. I see it. Okay. Gotcha. That's one of those pointy screws. Screws into plastic. Nothing like taking something apart and having spare parts. We don't want to do that. Okay, that should take care of that. Now the question is, our antenna here is still connected. Make sure those pads stay where they're supposed to. 1, 2, 3, 4, 5, 6, 7, 8. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. We have the right number of screws. Now the question is where the long ones go and where the short ones go. My guess would be the short ones would probably go over here, but I don't know that for a fact. So there's a short one. There's another short one. So we're getting the back put back on. So that puts those 2 on. And this is probably, the other one's right here and right there. And then the long ones will go on the other side. And these pads, we'll make sure those stay where they're supposed to be. The alignment looks good. So these are the 2 short ones on the back. Get this one in. The other short one. A little bit of a push to get that one lined up. Finally got that to grab. Okay, so that's in. Now we should be able to turn this over. We've got 1, 2, 3, 4. 1, 2, 3, 4. 4 more screws to put down. Our pads are in the right place and they're holding. So the one in the middle would be right here underneath the M.2. There's 1. There's 2. There's number 3. Number 4. No extra parts. Well, that was tedious. So if anybody asks, can you upgrade the card? Yes. Should you? No. That screw feels like it bottomed out. Okay, we've got all of our screws back down. Now we've got this M.2 slot cover because that one screw we had to get to put down. My only concern about this is it rattles. So I don't know if I want to leave this here or not. See, this one's not down tight, but it's leaving room for the M.2. But this one's not going to rattle. This one won't rattle because it's tied to all this, and the battery's underneath this one. And if we need to change the battery out, this one's easy to get to from the surface. But this one, so that we're going to leave out. Any of the rest of you feeling brave and want to try to go after that M.2, you can see what was involved, and that was nasty business. I would strongly encourage you not to take out that card unless you want to take it out and just leave it out. But if you want to upgrade it, it's possible. We did it. I think it'd be easier to pull hen's teeth, but we did it. So we've upgraded the M.2. We've got the CPU in. Now we need to get our cooler on, and then we can stick our RAM in. And the RAM is supposed to go, I believe, to the outer slots. I'll double check. And we've also got our our boot drive, our M.2 in here. So the next thing to do, cooler, memory, then we need to get this thing in the case. Wow, so far we've made some major steps. Now we're going to see about getting this cooler put on here. And one of the sockets I had to have to get one of those nuts off the bottom, I believe, was a 3/16. So if anybody wants to know, it's easier for me to tell you now than later. Special tools I had to have were a 3/16 socket. The Phillips screwdriver I had to have was smaller than a number 1. So I'll put that out of the way. And also another special tool I had to have. These are jeweler screwdrivers. This is a bent nose jeweler screwdriver. It's got a spring on it, keeps it open, but I use that to take the pins for the antennas off for the M.2. And we're going to have now Bluetooth 5. Maybe. Okay, so everything looks nice and clean. Boy, that was work. So what we want to do is make sure we get our CPU over here. We've got our goop to put on it, which is our thermal compound. I have the lid off. I don't think there's a seal I need to break. So I should be able to dot this up as they said. And we need to go back over that again. When in doubt, read the instructions. This is not the way I've done it. I've always put that stuff on and then use like an old credit card to get it where I want it, nice and thin. But I'm going to put it on the way they say. So we will put on our drops, and what I want to double check is how this is going on. These two are close together. These two are far apart. These two are far apart. These two are close together. So the way this mounts is this way. These two are close together. These two are close together. These two are far apart. And these two are far apart. We have the special Allen wrench right here that we'll use to put this onto that. And it's got a ball head on it, so it'll make it easy to move around a little bit. So we'll keep that right there. So as near as I can tell, I think we're good to go. Now the other issue with the battery, if we think we need to change the battery, now's a good time. But we've done that. I want to get onto that, and I want to get this thing up and running. So what we're going to do is we're going to take this off. And I need something that's cotton. I want to wipe that like a sock. Okay, we've got a sock. We'll clean this off. Top of this, we'll clean this off. Put the lid back on, set the sock aside. Now we're ready to put down our adhesive. So what we're going to do, according to the instructions, we're going to do a pattern. We'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'll do 1, 2, 3, 4, just like the instructions claim. And they say to use a bead, 9 small drops, 3 to 4 millimeter. I'm not a millimeter person, but 3 to 4 drops. So let's see what we've got here. That'll come right out. So there's 1, 2, there's 3, 4, 5, 6, 7, 8, 9, and then we'll do our 1, 2, 3, 4. Okay, that looks pretty good. One there looks a little shy. It looks pretty good. That one looks a little shy, and we probably used about half the tube, so we got that much still left. I'll screw that down. We'll have that later when we need it. Okay, so we've done our pattern 1, 2, 3, 4, 5, 6, 7, 8, 9, then the 1, 2, 3, 4. If we've done that correctly accordingly, then we should be good to go. We're going to get our cooler on. This goes in this direction because remember, the wide, the narrow, the narrow. So this should go straight down. Okay, down we go. Drop those in. So we're supposed to be able to get down in there. I'm taking that off. Yeah, that's much easier to deal with. I'm using my needle nose pliers to help me position. That is really awkward. Let's get these started. Now I like this cooler. I've got full CPU coverage. I really like that. Get my hand out of the way so you can see what I'm doing. I'm just gingerly going around and making sure these are secure until I start putting some weight on it. Okay, now then the tightening procedure on this. Only tighten the screws until they stop, but don't use excessive force. That's what I needed to know. We don't have a wrench that tells us to stop with these. We just keep going until it hits the bottom. So I'm going around a little at a time, Kind of like putting lug nuts on. I'm not going all the way down on any one of them. A couple of turns. Try and keep my hands out of the way so you can see. That one stopped. That one stopped. That one stopped. And that one stopped. So I'm going to go back and check them. That one's all the way down. That one's all the way down. And that one's all the way down. Just making sure they're secure. That one's probably the most secure. That all feels good. Okay, those are down. That's on. Okay, the fan's going to go back on the way it was. And they've got these little dampers on here. And the mount, which are these little brackets on the side, are already attached. So what I want to do is get out the other fan. We're going to put on this extra fan right here. We've got one fan. This fan here is going to go on this side, and this fan is going to go on this side. So I'm going to use this to look at. The clips to mount this fan with came with it, came with the cooler. All I had to do is get the extra fan. Noctua box. This is 150 millimeter. That's 150 millimeter. The clips on the ends are already on. We have separate extra clips to help make it quiet. So what we want to do is make sure these are both going the same direction. If you'll notice, the label's on this side, on this fan, which means the air, there should be an error. Yeah, air is flowing this direction. So this is going to blow this way, and with this fan, this too will blow that way. The air is on the bottom. So when I turn this up, the air will flow this way. This fan and this fan. We had to buy the extra fan. And what I'm going to do now is put these clips on, so I can look at the other and see how it's done. Now, some people don't like this funny color plastic that Noctua uses. I don't mind it because it tells me it's a Noctua fan. Noctua also makes black fans. So if you want to get the black ones, I like for this to show up. Also, it makes it easier for what we're doing. Otherwise, the black is a little hard to see for a presentation. Clips, clips. And that should go right on. Not much to that. Okay, our primary fan, which is this fan right here. This is the one we'll plug into the primary header down here. So we have our fan headers plugged in. So to reiterate where we're at right now, we've changed out to M.2. That was a bear to do for the wireless. We've got the M.2 NVMe drive installed, piece of cake. We left this cover off. We had one screw here to put the back panel on. We left this cover off because it rattled. This one is loose here, but it doesn't rattle. The battery's under here. We may deal with that later. Now we need to get memory in here. Once the memory's installed, we get this in a case. Once we're in a case, then we move to the next step. And folks, when you're building a new computer or when you buy a computer, be sure and save your packaging. Save it for the term of the warranty. If you've got 30 days, save it for 30 days. If you've got like a motherboard that's got a 3-year warranty, then you need to keep the box for that for 3 years. Otherwise, if you ever have to send the board back, which with Gigabyte, don't bother. But if you ever have to send the board back, you'll have to have a box for it. And that can get tedious. So I got a parts bag here. I'm putting all these extra parts in. And this was the mount that came with the CPU. I'm going to put that out of the way for now. I'll deal with it later. Now we need to go with RAM. Hard to believe that little stick of chewing gum is 1 terabyte. Okay, now for the big surprise, the big unveiling. The RAM we're going to use is Kingston HyperX, and this is a kit of 64 gigs. This we're going to put on this board. And what I want to do is double check right quick. Here's what we want. We're going to look at the manual, the PDF file, and we're going to do 4-channel, and it's important to pay attention to the way the sockets flow. Now then, we're going to use 4 modules, so we're going to go not DDR4 11A, but 22A and DDR4 42B. Now the orientation is, if you'll notice, it's the 2nd and 4th on the right side, and it should be the 2nd and 4th on the left side. So DDR4 82B and DDR4 62C. So we use the furthest on the outside, we skip one, and we use the next one. That's what we want to double check. Okay, we're going to break the seal on the memory. It's a factory seal, good to know. Hard to believe we've got a motherboard that did not have a factory seal on it. I've never, this is a first. But I can tell you folks, do not buy a used motherboard because you don't know what kind of care it's had in handling. And we've gone to extreme measures to make sure we don't have any problems with static. And you can see how much handling we've done. Okay, there's our memory, 4 sticks, Hyper. So we're going to go to the outer slots, skip a slot, and go to the next slot. Now, if we were to put all 128 gigs, would it fit under this cooler? I can take the fan out if it's a problem, but I don't think it's going to be a problem. This is DDR4. Notches on this end. I'll start with the outer slot first. It's interesting, these are fixed. These are the only ones that move at the top. So we'll start up here at the top in the orientation this way. So we'll put the bottom in first, in toward me. That should lock in. In fact, let me see if I can get audio here so you can hear that lock. Yeah, you should have heard that click in. I'll take another stick, same issue, turn it. Now if you notice with these fans, I'm going to be right up against the cooler. So what I'll have to do is slide that cooler up to get that in there. So let's do that right now. Take that off for just a minute. Set it aside. Memory. Check our notch. Pull the lever down. Bottom. Top. It didn't make as loud a click, but it still clicked. Now then, let's see what that cooler is going to need to do to be on top of that. And that'll just slide down in there. So I can keep the cooler where it was at. Now, if I were to put the other memory in, then what I would need to do is slide that fan up. And it could clear just underneath it. And I'm going to turn this up on edge because with this memory in, the question is, because we have the two outer slots and the two outer slots to fill the two inner slots, how's that going to affect where these fans are going to sit? This has to be slid up just a little bit. I'm going to turn this up on edge and see if I can show you. Now, that fan will clear that memory as long as that's raised up a little bit to put the other memory in there. But if I'm only going to use, and if you'll notice, I've still got full coverage on that cooler, even though I've raised that fan up. But the memory needs to be put in there first, and I am right above it. I got just enough room. So I put the memory, I took the fan off, put the memory in, put the fan back on, raised it up. I can lower the fan back down where I had so it's not sticking up here, but it's not going to hurt operation here, and I can still get the other memory in. So if I want to put 128 gigs of memory in here, this will still work. Cooler's not a problem, fan will clear. So I'm going to do the same thing on the other side with that fan so I can get that memory installed. Man, this thing's heavy. The motherboard was heavy to start with, but now that we've got the cooler on, it's even heavier. So we're going to raise this fan up, and what I'll do is I'll just pull it off. Clips will stay. Let that sit. So we'll get the other two sticks of memory in the outer slots. Turn the right way, watch the notch. This end first, then this end. Locks in. Now we'll take the last one, turn it over to this slot. Put this end first, then this end, and that latch comes right up. Okay, now the same thing, we'll take this fan and put on right above the memory. And if we choose to upgrade the memory later, it will not be in the way. Okay, there's the two fans right above the memory. Okay, we're in business. Now the next biggie, we've got to get the case up here so we can get this inside. So let me zoom out on this a little bit. Okay, this is the case we've chosen. This is the Corsair Obsidian 750D Airflow Edition. We've got 3 bays in the front. This case will allow us to have a liquid cooler in it or an air cooler, and we're using an air cooler. 3 bays in front, so we'll have a removable drive, we'll have a Blu-ray drive, and then we'll have a drive bay with our USB-C and USB 3.1 and USB 2 ports in the third one. What I like about this, lots of space. It's a little wider. I've got a window on the side. For what it's worth, it'll be nice to see what's inside of it. It's got plenty of cooling. The front, a couple of touch latches at the top. This panel will pop off, and there's 2 fans in the front. And that mesh is a nice open mesh that's easy to see through. Now I took the liberty to go ahead and get this out of the box because this is where I've always had the most troubles with static electricity. And there was a plastic film on the front. I took that off, and of course there was plastic on the side on the window. So the top also has a mesh. It'll pop loose, and when I turn it sideways it may pop off. We'll get this side panel off. Got a nice wiring harness inside. Plenty of stuff for devices. The standoffs are already installed for the motherboard, so that should be good to go. So I'll disconnect those wires and set them aside. We've got the 19 pin for the USB-C, power LED. We'll get all that connected in a minute. Now 2 fans in front, 1 fan in the rear. These are 140 millimeter fans. The fans in the front have motherboard headers, and the fan in the rear has a motherboard header. So that way the motherboard can control whether they need to run or not. That'll make it easier for me. If I turn this, I've got a drive cage here that I need to take out. That'll give us some more space. So we're going to do that right quick. Parts box is over here. And you don't have to have these installed. There's nothing really significant going on with cases, which is frustrating. Computer cases just have not gone very far. The glass is a neat idea, but they've gone so far with taking drive bays out of them. I like all my drives coming out the front. I don't want anything on the inside, but that's what they're doing right now, so we have to work around it. Okay, that gives me some more room to maneuver, and I'm going to need all the room I got. So I'm going to go and get the box for the parts out of the case. Now I'll be curious to see if we have a case speaker. So many cases have gotten where they don't include them, and I've had to provide my own. I like to hear that report from the motherboard, and there is no speaker in here, so I'm going to have to get one. I'm going to set this motherboard in here, and then I'll rotate this around so you can see what I'm doing. Plenty of room in this case to mount this motherboard. Plenty of room to do everything I've got to do. I've never had a motherboard that had the I/O panel fixed, but this one does. So all we need to do is get this underneath and where it needs to go in its little home, and we'll be in business. Change one thing changes everything. Now, can we put this same fan back in here? What we may do is put one of the 120 millimeter fans on here, because this is 140 millimeter, and that should clear that shroud. Got the fan out, and the I/O panel is right here, so we need to get this in. Yeah, that's a whole lot easier to work with. Bingo. Okay, there's the I/O panel, and what we're looking at inside here, we had to pull that fan off because of that shroud on that motherboard. And the shroud on the motherboard holds the two fans that cool that heatsink. So we do what we have to do. So right now that's in, and that's going to work. You can see where the cooler's at, and you can see what that looks like where the I/O panel is at. And you can see we got plenty of room in this case for everything we're going to do. We're going to need that space because we're getting ready to put a big video card in here. So let's get this thing tied down, and we'll go to the next step. Well, that's a big cooler. But if you'll notice, it'll clear the top of the case. It fits. This case will go with either kind of cooler. A liquid cooler in the top, front, they claim in the bottom. I don't know about that. Or even in the rear if you use the small one, but I prefer a liquid cooler in the top. Anyway, because of the bracket, we're using an air cooler, and it's a Noctua, and we're going to love it. And we got our 64 gigs of RAM, and this cooler will clear 128 gigs for those that are wondering. The I/O panel looks like it's lined up good. See if we're lined up on the standoffs. We are now. Okay, so we need to get our screws out, and I'm going to have a motherboard speaker. I like the fact that the standoffs are already set. Extra screws for fans. Some long screws for something. Some more pan head screws. And what we're looking for is a fine thread screw. So these with a pan head that it's a fine thread is probably what we're looking for. This looks like it right here. Now that camera's set on auto zoom. I thought it'd be easier than me trying to mess with it, because if I touch that camera, it'll wiggle. But this looks like what I want. I think that's a fine thread. We're going to check it and see. I'll use the regular screwdriver. Nah, if you'll notice, this long screwdriver fits all the way down and clears. The short screwdrivers, a lot of times you had to be cockeyed to get them to work. So let's see if we've got the right screw. Yep, that's it. So we've got 1, 2, number 3, number 4, number 5, 1, 2, 3, 4, 5, number 6, number 7, screw number 8. Oh, no screw. That's just a stud sticking up. That's a curious. Okay, so that's like a centering screw. So right there is the centering screw. It's just a thread sticking up. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2. That's interesting. 1, 2, 3, 4, 5, 6, 7. So 7 screws holding the motherboard down. And then that one in the middle is just a centering screw. So I have 3 of those left. Everything is individually bagged. Nice. Curious about the fan, if there's any way that can go back in there. Now we want this to flow this way, from front to back. So this particular fan would have flowed. I'm looking for an arrow on the fan. I don't see an arrow. The label is usually the way the air flows, this way. So that should have been that way. But there should be an arrow on here. 1, 2, 3. I don't see an error. So if that's the case, my wonder is, can it be put back on? Yes, it can. Wow, that fan will fit. Unreal. So we had to take the fan out because of the shroud, but it'll clear the shroud so we can put it back in. I didn't expect it. So we'll get the screws back in on the back. We will probably change these fans out later, but you know, hey, what the heck? Came with a case, so for now, we'll use them. They ought to last for, I don't know, maybe 3 years. If they get noisy, we'll pull them out and swap them out. So if anybody's thinking about building a second generation Threadripper, I'd strongly encourage you to. And if you don't think it's bang for the buck, with this processor, I think it is. Now, for a fan header, I've got a system fan right here, so I can plug that in. Now, this fan is only 3 pins, which is not what I want. That means this fan will run all the time. The fans in the front are also 3 pin, which means they will run all the time. That's not what I want. So we're probably going to change these out, but for now, we'll go ahead and hook it up. We'll see how noisy it is. And those are keyed. Those go on real well. Now, the next concern I'm going to have is the power supply. Because we have these 2 8-pin leads, there's plenty of room for those leads to reach through. But if the leads for the power supply itself are not long enough, I have some additional leads that'll make it stretch like I need to. Got those in red. Thought they'd show up good. And cable management, I need to tie that up, and I will later. So now then, to reiterate, we've got our case laid out. We've got our motherboard installed. We need to get our power supply installed. And the power supply we're going to use, now I should have already taken the plastic off of this. I have not. This is the EVGA 1000 G3. And the significance of the G3, it's the largest power supply we can get in the smallest package. And that was my goals. Nice thing about this, factory seal. We'll cut the seal. I like that. Manual. Everybody's got a manual for something. And a little bag to put the extra cables in, which is nice. Power cable. And all these cables for all these good things we need. And the power supply itself comes in its own little protective case. We'll pull that out. A lot of power in a small package. Totally modular. 100% modular. And that's the way to go. So what we want to do is decide our location. A lot of people like to install their power supply. If you'll notice the way I have this oriented, where the fan is on the outside to the bottom, I don't like to do that. I like that fan in here. I know, it blows air, hot air up into the case, but I don't like anything on the bottom because a lot of times there's no clearance here, and they're not having any clearance on the bottom causes problems with that fan. So I like that fan on the inside. So that's what I'm going to do, and that's the way I'm going to install it, and it'll show right here on the label what it is. And as I look at the wiring, to turn this up, it's got a little foot down there it sits on in the case, but everything's going to be upside down. Their expectation is this is the way you install it, so you can read the labels. And with what I've got SATA here, I've got motherboard here, I've got CPU 1, CPU 2, VGA 1, SATA 2, SATA 3, SATA 4, peripherals 1, VGA 2, VGA 3, VGA 4, and VGA 5. I'll have plenty of power to do whatever we need, so that shouldn't be an issue. But I'm going to install it upside down because I want that fan facing in. And this is the power supply that we had in the video when we looked at all the components. I've got the screws to attach the power supply to the case, so I'm going to go ahead and get those out and do that. 4 screws, and I can use my standard Phillips to put those on. Let's see if I can get this forward a little bit so you can see what I'm doing. Now the other devices and other peripherals that I need to put in the case, I'll do later. Our goal right now is we want to get this up and running successfully. We can add the other stuff in later. Now this has an on-off switch. It also has an echo mode on-off. I will say this for doing audio and video, anything that has a green mode on it, turn that stuff off, or else your computer may give you grief. When you start loading up virtual instruments, turn all that power saving stuff off. It's going to be interesting to see how this responds with that new wireless card in there. I'm curious to find out. Okay, power supply is tied down. Now we got 3 taps we need to do. We need to get the 24-pin tap onto the motherboard, and we got the 2 8-pin power taps. So I'm going to get over here to the cables and dig through that. There's one with the 24-pin. Now we're going to look. There's peripherals, SATA, and I'll probably go through these half a dozen times. VGA, CPU, 8-pin, VGA, SATA. I'm curious to see if those are going to reach. Now we're going to need to stand the case up, so we're going to take time to do that while we're at it. So we're going to stand it up. Okay, motherboard, that's the primary. These two secondary 8-pin taps. These anti-static gloves are holding up pretty well. I had read where people said when you get to handling some of the stuff on the motherboard, some of those circuits on the back, they'll snag. And they do, but these are holding up well. I bought 2 pair just in case. Okay, I got my cables out. Now I'm going to turn this so I can see it, because I need to be able to get these cables inside. And I may end up doing this 2 or 3 times till I get it where I want it. Let me lay that back down so you can see what I'm doing. Okay, I've got 2 taps that go next to each other. And this one with the lock goes to the motherboard. So we want to string that through and out through one of these connectors, probably the top one. So what I need to do is run that through, but first I want to get this connected. So motherboard, we've got those 2 connected. That shows up pretty good. So we've got this one and this one. We still have a tap over here to do, and we've got CPU 1 and 2. We're getting ready to hook those up, and then we're going to run this through this hole back here to clean this up. So now you can see from this side, we're going to take those cables and run it through. This one right here is probably the easiest. It's an easier flow instead of pushing it back, because we've still got one on the other side for SATA 1. So we'll run that out. We'll run that back in. We need to go up here and run that to the 24 pin. Okay, we are on the motherboard. You can see that tap. Now we've still got to take care of this tap over here, which is these 2. And to do those 2, we're going to have to get a little creative, but we've got a hole up in there that should pass that through. So let's take the next step and see if we can get this other one done. Now the question is if these will reach. They should, but we're going to have to double check them first. So CPU, ideal. I'll get the other camera out and show you in just a minute what I'm doing. What we're dealing with, and you never know when you're trying to do this how this is going to work, but trying to get these cables to come through. We've got this one here coming through on here, and then right up here we've got this other one coming through on this end, and there's plenty of room in the top of that case for that to work, which is great. There's a hole there for it. My concern was sometimes these cables are too short, in which case you have to do something like this. And I bought these ahead of time just in case they're necessary. We've used them in the past. These are 8-pin to PCI Express, and this gives us the 8-pin power tap to extend this. That's all it is an extension cable. I bought red because I thought we'd need them, and they're easier to see than these black ones, but these black ones are showing up pretty good. And you can see this is what I've got to get connected, but it's long enough that it reaches right up in here, and all I got to do is tie them in. So that's what I wanted to show you. And there's space in the case to route that cable up and over. A lot of cases in the past, that's hard to find. So I'm really pleased to see that. So now we need to get these plugged in. I'm going to plug in at the top for the motherboard, and then I'll plug them into the power supply second. The key goes to the top, so I'll plug in the lowest one first, and there's room to get my hand in there too, right above that cowling. Lock that one in. I'll take the second one, do the same thing. We'll run it through here, CPU, up and through. Plenty of room for that. I've had some of these where we've had to run the cables before we could even put the motherboard in. But boy, this case has got space. Now if we had a liquid cooler up here, this would be a whole lot tighter. Also, if we were using a liquid cooler, it would require one of our USB 2 ports. And while we're on that matter, if we decide to put a Thunderbolt card in here, for which we're waiting for a BIOS upgrade for that to work, because the header's on here, I haven't shown it to you, but I will. It would require a USB 2 port. So resource allocation, we're going to be slim on USB 2 ports. Okay, so the cables are plugged in at the top. Now all I've got to do is get them down through the bottom on this side. Okay, yeah. So now we need the other 2 CPU 1 and CPU 2 right down there. So CPU, the solid block goes down here on the bottom, and the split block goes on top. Okay, half and half. The first half put in, the second half put in. I'm surprised they didn't make those where they lock together. First one in, First half, second half. Now let's take a look up in there. We got those blocks in at the first half, right up in here. Got both of them installed. Those were in two pieces, left half and a right half, and then left half and right half. So those are done. So now let's get this down here and take a look at it. We get these put in. It's the same cable, plenty of room, plenty of length with this case. CPU 1, CPU 2. I haven't done anything to hold the cables down, but I've got everything strung in like I like. They're out of the way. I've still got room on the back side. I can do some work right here. So I've got the top done, I got the bottom done. I got the main power supply right here, 24 pin. So those are done. So the next thing we need to do, we'll lay this back down, and I think we're going to be ready to put a video card in. And then once we get the video card in, then we'll route power for it. After we get power routed, then we need to get our wiring harness hooked up. So we're going to lay this down, get the video card installed, get power to it, to the power supply, and get our wiring harness hooked up. Then on to the next step. Now we're going to get the video card in, and that's going to be an interesting piece. This is not a bang for the buck video card. What we wanted to do with what we've done from the 8350 to the Ryzen and now to this second generation Threadripper is we've doubled our memory, we've doubled our processing power. Now this has twice as many streaming processors as the previous card. Previously we used the Pro WX 7100. This is the Radeon Pro WX 9100. And in some aspects it's more than double. This is way overkill. Remember, the video card is mostly for your special effects so that they play in real time. But this is the card we chose. We'll benchmark it, spec it, we'll see what it does. Most people will probably be okay with the 7100 for the money, but this is what we chose, bang for the buck, we hope, for the machine we're building. Cables, the card, dongles. This gives us mini display port to HDMI and mini display port to DVI. Curious. Here's the card, and this is what we're going to put in this machine. Now this is a big card, it's a heavy card, it takes up 2 slots, and it's going to put it right up next to the cooler. So what I'm going to do is set this here for a moment. Let's double check what we have in this box. There's a bracket in here. This reminds me of a bracket like you would see on a not a Tesla card, but one of those Intel processor cards, where this bracket goes on the other end to give the card support. I don't know how well that's going to work in this case because there's nothing on the back side to support it. So hopefully we won't need this. But I'm curious enough to get it out and take a look at it and see what's involved. Screws and 2 plates. So we'll see once we get it out. We've got all these other dongles. We've got, and they have a clip on them, mini display port to display port, mini display port to display port. We have 4 of those. Mini display port to display port. And then this is the other pin if you decide to use it. We're not going to install this, but this is for the 3D stuff. We're not going to be doing that, but it's there if you want it. Okay, we've got to get our screwdriver out. We need to pull a couple of these out, and it's going to be right up against the cooler. So we'll pull out number 1, pull out the panel, pull out number 2, pull out the panel. Now these have special locks, PCI Express slots. Flip that down, get this out of the bag. This is a single fan, the Radeon Pro. It's got a plastic cover over the shroud, so we'll pull that off by all means. That's beautiful. There is a connector here on the top. I'm not sure what plugs into that. That may be for putting 2 of these together. I can't imagine such. And we've got power in the back, an 8-pin and a 6-pin power tap. And then the bracket, if we were to put it on here, would go on the back like that. But there's nothing to hold it up that I'm aware of, so I don't know. There's nothing in back to support it, but it's there. Boy, we are right up on that cooler. Now this board has a protective cover on the back, so the circuit board is not actually touching the cooler, but I mean we are right up there. Okay, that's locked in. Now all we need to do is screw it down. It's a full-length card. There's the one connector right here for that little 3D connector that goes on an I/O card that we're not going to use. And I'm not sure what this is unless it's a link to put two of these together, and I can't imagine. The video card needs to be one card in a machine. All that stuff they used to do, they're getting away from. So we just need to lock this down, and we're going to have to work that just a little bit. The alignment on that's a little bit rough. I'm having to push this into the video card to make these screws line up. I'm pushing this way. Okay, the video card's installed. It's locked down. I don't see any problems with it having sway. We can still get to our SATA ports. A lot of times SATA ports have been underneath the video card, and that really stinks. So what we need to do now is to find two power taps, our 6-pin and 8-pin for the video. G3, lay that right there, or right there. So we want to route these through one of those holes so we can have a nice clean installation. So we'll take the cables off. There's one, VGA G3, there's number 2. Now if you'll notice, these have, this one's a straight through, this one does a Y, and I really don't want to use a Y, although I can, so I'm going to use this other one that's a straight through. Considering this card, we're going to make sure we get lots of power for this. So the 6-pin and the 8-pin, that'll be what goes to the card. So I'll go ahead and hook those up first. Now that block locks together. That's nice. And the key is on this side that locks it down. So the bottom one is the 6-pin and the top one is the 8-pin. So we'll pull that back. We'll do the 6-pin on the bottom. Then we'll put this block together. And we'll do the 8-pin on the top. Key facing toward me. 2-pin, 6-pin. There we go. Okay, we got our 6-pin on the bottom, 8-pin on top. That was a little tricky getting that together. Okay, now we're going to take these two cables, we're going to route them through the back and then back down over here. So we're going to need to stand this up while we do this. Okay, we're going to take those two cables. They're in close proximity, so we'll run them straight out through here and then back in at the bottom right here. Okay, we've got those cables routed out, connected, and now we're going to take these down here and plug them into the power supply. So far so good. VGA and VGA 1, 2, and 3. VGA 1, we will go to VGA number 2. Now you can see we've got, right here we plugged in VGA, VGA 1, and VGA number 2 right here. These other VGAs we don't need to worry about. We're not going to use those. But the SATA ports back here we'll use when we start getting to that stuff. But we're not dealing with that right now. We want to get done what we need to get the machine up and running. That's our goal. We're going to need to do some work with these cables to get them nice and flat. They may be fine like they are. And when we do, we'll put the lid on, but we're not there yet. Now we want to tackle a wiring harness. The only thing that matters is getting those front cables put on. I need that speaker, PC speaker. They're just not including them with cases anymore. Bought a bag of them so I'd have one when I need it. I like to hear that beep so I know what's going on. Old fashioned, I like to know what's going on. Okay, so we're going to take this, we're going to put it on the motherboard. So what we need to do is we need to check our pinouts for all this right here. So what I'm going to do is bring up the PDF file again, and we want to see the pinout there for number 13. Now while I'm at it, I'm going to show you here on the manual. You notice that little block right there? You see number 16 and number 11? Number 11 is your SATA, number 16 is your front panel USB-C, that little blade connector. Well, right there is a connector. I'm going to flip over when I get through with the pinout when we go back, and I'll show you. And that is the Thunderbolt header. There is no documentation in the manual on it. Here we are, the front panel header. Okay, now as we look at that, the orientation being to the bottom of the motherboard, that should be right there. That's the PC speaker. Okay, now the next one, curl that down so we can look. The next one, HD audio, we can get that out of the way. That's way over here. Now this will be keyed, one pin blanked out. Cable could be a little bit longer, but it'll do. The USB-C, we don't need it right now till we get this other done. What we're looking for is a power LED and a power switch. There's a reset switch, power switch, hard drive LED. Okay, hard drive LED is on the bottom, positive faces out, and that's opposite. So the hard drive LED positive faces out. There's marks on here. The cables aren't color coded, but the connector is. Put me a little light on here so I can see. That should take care of that. Okay, and then the reset switch goes right next to it. Power switch. These two are power LED. Power LED goes right above the hard drive, and the red positive and the markings are positive. Those connectors are, one of them's on. There we go. So we got the power LED. Now we've got the hard drive. We need the power switch, and the power switch goes right next to the speaker, and positive goes to the left is correct. That should be the power switch. So we have the power LED, the power switch, the hard drive LED, the speaker, and what's left? The reset switch. And the reset switch is right next to the hard drive LED, and it goes in the opposite direction. Hard drive LED went that way for positive, and the reset switch for positive goes that way. So reset switch, if the print is the correct orientation, because there are no markings, so I have no idea which one of these is power, unless I go with the one with print on the edge. If that's positive, then it would be the direction of the switch, positive on the right side. So that will go right next to the hard drive. I can see to get it on there. Now, if that's correct, the other two that are left that aren't doing anything are for the chassis intrusion header that we don't have, and a 3-pin power LED. So we're using the 2-pin power LED here and not the 3-pin there. Okay, if everything is correct, that should be good to go. We've got these other fans still to hook up. Let's go ahead and do that. We still got fans to put in the top. We can do that later. Let's get these fans running. And fan headers we have. I'm curious to see how these case fans sound. We're going to need to change these case fans out so we can get full control of them. Okay, case fan, 3-pin header, 3-pin header. Okay, do a double check. Let's do the USB to the front. So we'll take the USB 3.1 front panel, and that is keyed. So the 19-pin connector, that's one, and then the case USB 2, 1 pin blanked out, and that's plugged in. So we should be good to go. We've got our CPU in, we've got our cooler, we've got our memory, our fans on the CPU are plugged in, we've got our NVMe drive, we have our video card installed, power supply. Power supply is connected to the motherboard with the 24-pin, the 2 8-pin, and the 2 connections to the video card for a 6-pin and 8-pin. So we should be ready now to check this for a smoke test. That's the machine built. Now we need to get a monitor up here. Now then, we need to get a keyboard up here. So that we can get this up on screen, you can see what's going on. We're going to take the mini display port, come out HDMI, so we can look at the BIOS and see what's going on. Out of that converter, mini display port to HDMI. We're using a decimator for the converter so you guys can see what's going on. Sure is strange looking on a computer not seeing any USB 2 ports. Everything's USB 3. Resource allocation. Remember, this supports PCI Express Bifurcation. We should be ready to turn this on. Turn the power supply on. Let's punch it and see what we've got. Now I'll flip over to that screen as soon as this comes up. Okay, reconfigured, it booted. I don't see anything on the screen yet. There it is. Okay, reboot and select proper boot device. So let's get back into the BIOS. Should be able to hold down the delete key and get into the BIOS. Okay, that did it. BIOS has been reset. Now I'm going to see if we can flip over. Now you can see what I'm seeing. BIOS has been reset. Please reconfigure your BIOS. Setup items if needed. So we're going to say OK. And if you'll notice, this particular BIOS, oh, it doesn't give the date up there. Gives the date but doesn't give the firmware version. The few things we need to go into because we're going to install Windows, we've got 2 USB 3, 2 USB 2, so we have 4 USB ports on the front of this case. When we put in a removable drive, a Blu-ray drive, and then another drive in here, when we add this drive bay, we'll have USB-C, 2 USB 3 ports, and 2 USB 2 ports. And depending on device and resource allocation, we may have to shut off those 2 USB 2 ports on this drive bay because we're going to need them for the Thunderbolt. And that's something else we're going to do later. So right now what we want to do is go into the BIOS and see what we've got. Let's put our memory stick on here. This is going to reboot. And we are going to install Windows 10 Pro. So we'll plug this in and we should be blowing and going here in just a minute. And there's the Aorus logo. We are booting, and it should see the stick, and that is Windows installing. We are now installing Windows 10 Pro. Hello everybody, thanks for watching. Hope you enjoyed this. Appreciate you taking the time to see this video. Appreciate if you subscribe. We have now built a second generation Threadripper, and the biggest problem was getting Windows 10 Pro installed. So I hope you enjoyed this build, and we're going to have some more information for you soon. Thanks for sticking with us. Thumbs up will be appreciated, and we'll look forward to seeing you next video. Have a great day. Thanks for watching.